All right, here we go. I am super excited for our episode today. I am joined by Mark Fussell and Joran Schneider. We're going to be talking about building resilient AI agents using Dapper, all running on Amazon EKS. All right, I'm really excited to get into this topic today because, of course, it's very topical to everything going on out in the world of AI right now, especially with the rise of agents. But Dapper has been around for quite some time. The folks that I have on with me today are probably the best people on the planet to talk about this capability because they are the co-founders of Diagrid, the company behind Dapper, and we've got the CEO and the CTO on here with us. So excited to have you guys. Welcome to the show. Welcome to the couch. Mark, I want to start with you. Tell us a little bit about yourself, the story behind Dapper, the story behind Diagrid, why you guys set out on this adventure.
Well, first, fabulous to have us on the show. Super excited to be here and kind of talk about this. Yeah, Jeroen and I have a huge passion for building distributed applications. A bit of background myself. I spent many years working in technology and spent 20 years working at Microsoft, building all sorts of large-scale services there. But what we encountered in our time there was, developers both within inside the services we were building in Azure, but also particularly in all those enterprises that we worked with. They struggle to build these durable, long-running, resilient applications that run on platforms, like Kubernetes, for example, like on EKS. And so we realized that we really had to work and do something to help them. And so that's kind of where we came up with this idea of, we had to build and codify a set of patterns that developers used when they built event-driven applications, or they did discovery between services, because they were distributed in nature. And we could codify those patterns, give them as a set of APIs or a set of building blocks, and dramatically increase the productivity of how developers build these services and make them more resilient. They seem so easy on the surface, but boy, is it hard work for them to do this. And so that's where Dapper was born. Both Jeroen and I kind of sat down and we came up with this idea of creating a set of APIs. That Dapper project was released over 6 years ago now. So it's been around and very mature as a project. And today, it's actually a graduated project donated into the Cloud Native Computing Foundation. So, very excited to talk about more of it today.
Yeah, that's awesome. And I know we were chatting a little while back, and I was gonna ask the question, where did you come up with Dapper? But then, as you said, distributed application runtime, the app, or okay, I put that together in my head, and then obviously the play on Dapper. I love it. And yes, you mentioned it's an open source project. It's graduated in the CNCF, which is a pretty big deal. It means we're seeing a number of customers use this in production and leverage this as a best practice for developing their applications. So, Joran, I want to go to you next. Tell us a little bit about what you do at Diagrid. Tell us about Dapper, and maybe give us a sneak peek into what you're planning to demo for us today.
Yeah, so as Mark mentioned, Dapper is a set of APIs for developers. It's pretty general purpose. You'll find anything from being able to write event-driven applications. So for example, let's say you're running on AWS in EKS and you want a really easy, secure way to connect to AWS SQS or to ActiveMQ, which is back the RabbitMQ. And you want to create this consistent API layer in your code that doesn't change based on the underlying infrastructure that you're using. And you want built-in telemetry, you want built-in tracing, you want circuit breakers, retries, timeouts. Dapper gives you all of those APIs to connect to message brokers, state stores, caches, secret managers, you name it. Every form of AWS service that exists, Dapper probably has an integration with it because we have an amazing community. And we're continuing to receive contributions all along. We have over 4,000 individual contributors, which is great. And we're welcoming more. So if you're watching this and you want to pick up the Dapper code base, please go on github.com/Dapper, pick your favorite repository and please contribute. But then, Dapper gives you these APIs and the ability to hook into existing systems, but it also has some really amazing capabilities for running long-running workflows. which is a workflow-like programming model where you can basically orchestrate a bunch of business processes and make sure that they're resilient to things like failures and pod crashes, network restarts, network partitioning, and any form of failure, really. Even if an AWS region goes down, your application should still be recoverable and the state should be kept within the Dapper system. And then when everything goes back up, Dapper should just recover your application. This is called Dapper workflows. And I really encourage everyone watching this to pay close attention to this. Definitely the most widely used API in Dapper as of late. And this lends itself really well into agents, which are essentially workflows that are non-deterministic in nature, which is something very scary because, for the past 30 years in software, we've been used to coding code that, we can debug and we know what it does because we look at the code and we know that it statically compiles to something we can expect and predict. But now you've got all these agents who are basically dynamically picking up the work because they're non-deterministic, because they're talking to LLM, which can never be deterministic. And so they come up with a plan. The plan will be different from one invocation to the other. They basically go off and execute a bunch of steps. And if something fails, well, they have to restart from the beginning. And that can be very costly and also very programmatic for just the resiliency of your overall apps. And Dapper plays really well in that today. And this is what we're going to see in the demo.
I love it, and we're moving fast here, folks. And Yaron is kind of has got an excellent demo for us that's going to show exactly how this works. But we talked about a lot of things. We talked about components that help customers build applications. We talked about this capability workflows, which kind of lends itself to the idea of agents really well. And I think what would really help us is to first visualize what the Dapper stack looks like. Like, what are the APIs? What are the capabilities that allow all this to work? So let's get into that. Mark, I'm going to pass it to you. I think you've got some diagrams here for us. And very quickly, folks that are tuning in, drop us a line in chat. Let us know where you're tuning in from. Gaurav, welcome from Barcelona. Glad to have you joining us here today. All right, Mark, over to you.
Yeah, let's dive in and let's kind of pull up that diagram. And this is a great view of the Dapper APIs inside here. And you can see that in the center there, you've got APIs for around workflow, publish and subscribe, service invocation, state management. And effectively, they codify all these best patterns and practices. So let's dive into a couple of these. Publish and subscribe. You're building an event-driven application. You have to send messages between two different services, service A and service B. It's asynchronous messaging pattern around these things. What you want to be able to do is have those exact semantics. I want to be able to publish messages that go on topics, and I want to be able to subscribe to those and receive them all and do this all asynchronously. And that's exactly what Dapper provides. It's incredible API that allows you to layer that, as we already mentioned, on top of any underlying infrastructure. So this plugs into AWS SNS or Kafka as a different type of message broker. But importantly, your API remains consistent and provides you all the right level of message security. You can do bulk messaging inside all of this and all of the right abstraction around this. So it's, you then effectively can put that together, for example, with the workflow API. And the workflow API provides you this long-running, durable execution. The fact that you can actually stitch together and coordinate a number of different services. So, for example, you might call onto a payment service, and then you might call onto another email service, and you want to make sure that all that gets coordinated together. You make sure that there's a failure, it does a retries, it does telemetry. And so very often we don't treat any particular piece of code like workflow as an island, but you've got to combine it with pub/sub messaging. You've got service invocation inside here, which does a request reply. And then you see across here, we actually have other APIs, for example, the conversation API that allows you to hook directly into LLMs. And behind that, you can plug in Anthropic or AWS Bedrock or any one of these others. And then on top of this, as a developer, you can basically use any SDK. So we come in as multi-language. You can build it on top of Java or TypeScript or .NET or Go, any language of your choice, and then hook that up to your underlying infrastructure. So by combining these APIs together, you're incredibly productive building and deploying applications onto Kubernetes as an environment, for example.
Awesome. And this integration with Kubernetes, of course, Dapper being a graduated CNCF project, I'm assuming these are implemented in a Kubernetes native way, right? Like CRDs, just anything all of these APIs can be connected through YAML resources that, developers and operators can manage through their infrastructure as code automation, right?
That's absolutely right. Dapr is installable via Helm. Our Dapr CLI also installs natively in Kubernetes. It manages the CRDs. Every type of Dapr component is a CRD also, and we'll see some of that in demo.
Cool. Sounds good.
Exactly. So what's great about this, and the thing that and this is one that I see that's encouraged quite a lot through the design and architecture best practices, that you have to accept that there's kind of code evolution. You might start with, for example, SNS as a message broker, but then you might decide that you want to move to Apache Kafka later, or to have some flexibility, or maybe you run both of them side by side, or communicate between two different teams. And so effectively, it provides you this not only portability that you can choose between different message brokers, but code evolution around these things. And I think that's really important as part of your design, without having to rip and replace a whole set of code that you bound into a particular SDK for a particular message broker, for example. So that code flexibility, code evolution, evolving architecture is really important, and one of the sort of the main benefits that Dapper provides.
Excellent.
If we go on to the next slide and sort of dive into that, we'll take a great example of how effectively you can sort of combine these together, and see how these can be worked and coordinated. And here I have an example effectively of a sort of a fictitious ticket reservation system. So you see here it's running a durable workflow. It does a reserved ticket activity, which goes off and calls by secure messaging through a message broker to talk to some other external system to book your tickets. And there, of course, you're combining effectively this long-running durable execution of workflow with the Pub Sub API. Or in the second case, after you've completed that, you might go off and call onto a payment processing service. It might be sort of a direct request reply. We use a thing called service invocation for that allows you to do direct HTTP or gRPC calls onto another external running service. And then finally, you see in the third step there, you might want to send an email to notify what's happened. Dapper has also the different bindings to all sorts of integration systems, where you want to send off email or you want to talk to other communication systems. And so effectively you combine these APIs together, particularly based around workflow, which, as I said, your own point out, is kind of like the hugely popular one because it solves a really hard case of coordinating across lots of different calls and does that in a durable manner. So you see at the end of this, you get the durability, you get the resiliency, you get the communication to external systems, you get telemetry, and you get this entire sort of package of APIs put together for you. And it's very much like building blocks you stick together.
Excellent. And I think these are all components that we can visualize through this architecture diagram, but it's hard to really, I think, for me to still understand at what phase Dapper fits into the development lifecycle. So hopefully, Mark, you're getting to that next, or maybe we'll see that through the demo.
Yeah, we'll see that in the demo where you can essentially code an agent, and we'll see how Dapper seamlessly fits in. But essentially, every type of developer who has a system to write that constitutes of a bunch of steps, this is exactly where Dapper fits in. So if you need to stitch together reserving a ticket and then calling a certain API, getting the response back, saving it to a database, notifying another downstream subscriber, this is really where Dapper Workflows basically coordinates all of these different steps and makes them stateful and recoverable and long running. So Dapper really catches the developer at the very beginning of their developer lifecycle.
Got it. Mark, is there any other diagrams you wanted to show here, or shall we get into the demo?
No, I think let's dive into the demo around these things and see what that looks like. But I think another important point, by the way, is that Dapper isn't just reserved for greenfield applications. It's very common for people to have an existing application and they want to make it cloud native, let's say, more running on top of Kubernetes. They're sort of evolving and deploying it there. And so we see many deployments where they take an existing, say, Java code and started to integrate Dapper just as a small piece of it. You could just use one of these APIs. You don't have to consume it all. You could just use, for example, the messaging Pub Sub API, which is often we see a common starting point integrating with an existing system. So I think that's an important thing as well. It's not just for greenfield, it's brownfield and all sorts of your code migration.
Got it. Makes sense. Yaron, feel free to share your screen and let's go ahead and get into the demo.
Okay. Yep.
All right.
I am sharing the screen.
Nice.
And so today we're going to be talking about how to run durable agents for production-ready workloads on EKS. And production readiness is extremely important. A lot of the stuff you're seeing right now going around by a bunch of demos is essentially great for very small deployments, and when you're taking into production, you really have to pay attention to things like reliability and durability, and the fact that every step of the workflow in the agent is actually stateful and that it's observable as well. So how do we do that in Kubernetes easily? Well, Dapr lends itself into this scenario in two ways. First, it can enhance existing agentic frameworks, and we're actually going to see how you can take a LangGraph agent and run it on EKS and just make it durable by default, and also save its state into DynamoDB, which is not available just with LangGraph today. Like, you cannot do that, but with Dapr, you can actually save it into DynamoDB. And then we're also going to be taking a look at Dapr Agents, which is Dapr's own agentic AI framework that has workflow durability built into it. And it is essentially the only vendor-neutral agentic framework, really. So we're going to start off with the latter, actually. We're going to be taking a look at Dapr Agents, and then we're going to see LangGraph. Both of them are going to be deployed on EKS. So what I have right now in VS Code here is the Dapr Agents repository, just git cloned from the repo. And in quick starts, I'm essentially going to be running quick starts that everyone watching this can just run at home, or in the office, or if they're working from home, it's the same thing. You actually go into this directory here, and you're going to have a bunch of steps that you follow. So let's start to take a look at what does an agent look like before we go into all of the Kubernetes stuff. There is this directory here, which contains the code itself. The one above it is essentially for the Kubernetes aspects of it. And the example we're going to take a look at today is a multi-agent collaboration. We're going to be creating an agent mesh. So essentially a bunch of agents coordinating together to accomplish a task, or should I say the one task, which today is to take the One Ring to Mordor. That's our canonical example. And so we actually have a bunch of agents here, an elf agent, and a hobbit agent, and a wizard agent, which in our case now, they're in the quick start. They're Legolas, Frodo, and Gandalf from Lord of the Rings. Also, shout out to our boy Roberto Rodriguez from NVIDIA, co-maintainer on Dapr Agents, who wrote this tutorial and most of Dapr Agents, really great stuff. And so we are going to start to take a look at what an agent looks like. And this is essentially all you need, and I'm highlighting it here, to create a durable agent that can communicate with other agents through whatever AWS infrastructure you have. And I'm just going to start explaining this. So the first thing you have here is a durable agent. A durable agent means it's a class that lets you run an agent that will keep its state in how many steps it's taking. And if it's executing 50 tools through MCP, or through whatever other means, or if it's talking to other agents, and one of those agents fail, or if the process fails at any point, the agents will pick back up where it left off with all of its state in place and intact, which is going to save you a lot of money because you're not going to have to pay for all of these LLM calls to start all over. And then your workflow is also guaranteed to continue. So whatever client was starting off this agentic workflow is not going to receive a failure. It's essentially going to just execute to completion, which is important. So we're giving the agent a name. Here it's Legolas. It's an elf. We have the goal: act as a scout, marksman, and protector, use keen sense and deadly accuracy, blah, blah, blah. And there are some specific instructions for how to speak. And here we're actually tying this into the Dapr ecosystem. So agents need a way to communicate, and Dapr gives you at least once delivery. So the communication between agents is extremely resilient because you can hook up any AWS supported message broker. So here we're telling it to use message pub sub. I'm going to show you what the implementation is in a sec. In this case, it's Redis. It's running on EKS as a container, but I'm also going to show you how you can actually, with 5 keystrokes on the keyboard, change this to be SQS or Kafka or RabbitMQ without doing anything else. This is the state store name where you keep the agent state. In this case, it's also Redis, and then I'll also show you how to save that later on into DynamoDB with LangGraph, but this also can be any AWS-supported database, any RDS flavor you want, or really just any form of database you take from the AWS Marketplace or run as a container yourself. And this is where the agents register themselves. It's another Dapper state store. And these keys are essentially table names inside of those. So we don't actually have to have those. They just default to certain values, but this can really be anything you want. And then since agents essentially send messages to each other through a topic-based system, the Dapper orchestrates, you give them a topic. In this case, we're calling it beacon channel. Beacon because in Lord of the Rings, whenever they want to communicate between separate areas, they lighted a beacon. That scene is very memorable to me. So yeah, this is the elf agent, and let's take a look at the hobbit agent. Exact same thing, just a different name, different role, different goals and instructions. This is Frodo and Hobbit oriented. Here we have Gandalf, exactly the same agent, and all we need to do is just call in each one of those agents and have them start. So I'm just going to zoom out a little so that you can see that this is really all it takes to essentially create a virtual environment of the Fellowship of the Ring. And then we can basically give them any task. So we're going to essentially be firing off multiple tasks. One will be to take the ring to Mordor, and then if we have time, we can tell them to advise on which card to pick in 2025, which can lead to very hilarious responses, especially with these set of instructions. It can lead to some very unpredictable stuff sometimes. Okay, cool, great. So the only thing that we have left to see, the only missing piece in the puzzle is what's called the orchestrator LLM. Each one of these services is its own pod on Kubernetes. It's its own container. We're going to see that in just a second. And we need to have an LLM that basically decides, which agent to call and in what order and how to orchestrate them and when the task is actually complete. So Dapper Agents has a bunch of ways to do that. It can pick them randomly. It can go round robin through all of the available registered agents, or it can actually use an LLM to get the instructions and the names from all of these agents and then reason about which one of the agents is the best to pick. And this gives you a lot of accuracy. So that's what we're going to do today. This is essentially all of the code you need to create an LLM orchestrator. These are all of the other properties we saw from the other agents. We're connecting it to a message bus, we're connecting it to a state store, and we're calling it LLM orchestrator. And it doesn't have a role in instructions because it is essentially providing the role of an orchestrator between all of those other agents that registered, and it's called LLM orchestrator. This is the type of the class. So this is all we need to essentially run this. And now let's take a look at the EKS parts of it. So the first thing we have, we've looked at this message pub sub and workflow state store, and you might be wondering, well, what are those in my deployment? So if we go to pub sub, you can see we have a component. This is a Kubernetes CRD. It's called message pub sub, and in this case, it's pubsub.redis, and it has specific metadata. So let's say that we wanted to take that agent and have it communicate with all of the other agents, not through Redis, but through something like AWS MSK. The only thing I would need to do then is simply go here and replace Redis with Kafka. Literally, that's it. And then the metadata, this can actually even be deleted completely, because if you're running with IAM roles, then Dapr will essentially just pick up the IAM role and communicate with a proper role that was given the pod. But this is really all you need to do, right? So you can switch like to SQS or RabbitMQ, which can work with AWS ActiveMQ. And this is really all you need to just switch it around. In this case, we are talking to a Redis instance that's deployed as a container within my pod. We'll see that in a second. And we also talked about the state stores, right? Same thing with the state store. Previously, we had state.redis. Now we have state. So we had pubsub.redis. Here we have state.redis. So this also can be changed. If I want to DynamoDB, I'll just do something like that. Nothing in the code changes. And this is the
what seems really powerful about this for me is the fact that you're able to switch between the types of services that are backing these various components with the flip of a config. So for example, teams that want to test something in their staging environment, but then when they're ready to go to production, it's as simple as just flipping that from maybe an in-memory or in Kubernetes Redis backend to their actual maybe some managed version of Redis, right? Like a DB as a service. That seems like probably a decent use case for something like this.
Yeah, it's also a very common use case, and you bring up a really important point. Dapr also provides in-memory implementations of all of those, so you can mock tests and write tests against the in-memory ones, or if you just want to spin up an environment that doesn't need any form of infrastructure. If the dev team wants to be able to be completely isolated in their own namespace and not need to be bottlenecked on the DevOps team to spin up a test database or whatever, they can just use the Dapr in-memory implementation, and we literally call it in-memory, right? So I could essentially do this and then start working against an in-memory implementation of PubSub.
So I'm
Yeah.
curious, in the code itself, like for example, in the Python code or maybe Node.js or whatever it might be, is there like a Dapper SDK that interfaces with these components? Like how does that get set up?
Yeah, there is. So let me go real quick to the Dapper Python SDK, and I can just show it there. So if you go to our examples, let's do just a very specific example. Let's take a look at PubSub. So let's go to Publisher. And this is what you'll have, right? You'll have with Dapper client, this is all you need to do. So at that point, this becomes your entry point into the AWS ecosystem, because you have publish event, and that publish event has the PubSub name, right? This could be pubsub.redis, pubsub.sqs, MSK, whatever, Kafka, and you just change the YAML file, and this code doesn't change. So when you're running in your local machine, this can be an in-memory implementation. When you bring it into your dev environment, it might be a local Redis. When you deploy it into prod, the platform team or the DevOps team can essentially change that to be something like MSK, and the code doesn't change one bit.
Yoran, it's like you're a mind reader. That's exactly what I was going to talk about next, was like the advantage this poses for platform engineering teams that need to be able to essentially configure what their app teams are leveraging across their dev, test, staging, prod environments. So yeah, I see the value of abstracting away these API endpoints through the client here. Okay, this brings it full circle to me. Thank you for showing me what it actually looks like in the code.
Of course. And yeah, we're definitely seeing more adoption of Dapper coming from platform engineering teams in the last year and a half, I would say, than just regular development teams. So this is really interesting. Okay, so going back into our demo here, we have our PubSub component. We took a look at the state store, and this is really all we need. And then we have our deployments. This is nothing special. This is your regular Kubernetes deployment. It has the image here providing a secret to talk to OpenAI. Dapper agents can talk to a variety of LLMs. It's actually abstracting them. In this case, it's going to be OpenAI, but it's going to be Bedrock. It could be Bedrock. It could be Anthropic, Mistral, whatever. And we're just going to be deploying these Kubernetes deployments into EKS. And the only thing I would call out here is that you have those annotations. This is essentially on Kubernetes telling Dapper to inject a Dapper container within your pod that provides those APIs for your application to be able to talk to. Another really cool part about Dapper is that it gives you identity. So each Dapper-enabled service or microservice or AI agent has its own identity. And this is really great if you're doing stuff like A2A or talking between agents through Dapper, and then you can impose ACLs and security boundaries. But this is something for another demo and another time. So we've got all of these different deployments for all of our different agents and for the LLM service. And what we can do right now is just go ahead and kick it off. So let me, first of all, show you my Kubernetes cluster. I have my Redis instance running. This is EKS. Let's do get nodes. And we can see that it's running US West 1, based out of Seattle. So that's nearest that's here to me. And we also have Dapper installed. So how would you go about installing Dapper? You would do something like hell install Dapper. This is really all you need. I did that before a demo to not wait those 30 seconds for the containers to spin up. So you essentially do that, and then you can do kubectl get pods on Dapper system, and you're going to see all of the Dapper control plane pods running. Now, I'm just going to give you a very brief explanation of what these do. This sidecar injector, essentially every time you see a deployment file like this that has Dapper enabled, it makes sure that the Dapper container is injected into your pod. The Sentry service is an identity service, Every time a Dapr-enabled service comes up, it gets a certificate that contains its ID, and that can be used for mutual TLS when you're talking between agents or when you're talking between services. And then these 4 pods are essentially the backbone of the Dapr workflows engine, and they essentially keep state and coordinate the transactions and all of the recurrent jobs running whenever you're kicking off an agentic workflow or just a regular workflow that you can also write with Dapr. And the Dapr operator is essentially just something that runs in the background, and it alerts various Dapr containers about configuration changes. So, for example, every time you're changing your Dapr CRD, let's say you want to switch from, I don't know, state.dynamodb to state.redis or vice versa, then the operator will essentially broadcast that change to all of the Dapr running instances, so you don't have to restart them, for example.
So Yoran, I've got a question. So
Sure.
I see this sidecar injector, and there's another very popular use case or user of sidecar injectors, which is Istio.
Yeah.
And Istio had basically presented some challenges with that approach of, as you get to a large number of scale, right? Let's say thousands, maybe tens of thousands of microservices. What's the implication on the latency, the additional sidecar containers that are running, taking up additional resources? So I'm curious to hear on how you approach that challenge, and whether, tell me if this makes at all any sense. Istio has this new approach called ambient mesh, where they're essentially leveraging the Z tunnel so they don't have to deploy sidecars to intercept requests. Would that approach ever make sense for Dapr? And how are you tackling this challenge with scale?
Yeah, great question. And I have 3 different answers for you. So first, Dapr has something that is exactly like Istio Ambient. It's called Dapr Shared, and it works exactly the same way. You can share multiple Dapr instances from multiple instances of your application. So you can definitely use that. That's one thing. Of course, both Dapr Ambient and Dapr Shared have some disadvantages because, for example, in Istio Ambient, if the Z tunnel in the node goes down and you have 100 containers running on that node, each and every one of them will essentially stop communicating, and your layer 7 capabilities just won't work anymore. And that's a big problem. But Dapr essentially has that same thing, just without that single point of failure. Of course, Dapr and Istio are completely different things, but this injection and shared infrastructure variants are fairly similar.
The sidecar here that's not an Envoy proxy, or is it?
No, it's a Dapr process, Dapr Go process.
Gotcha.
Now, the second aspect is, yes, lots of Istio sidecars can become slow, and that's mainly because Istio uses IP tables, which are essentially routing through the Linux kernel. So if you have thousands, as you've pointed out, if you have thousands of services running in a single cluster, you'll essentially have in every node that's running these pods 1,000 rules and 1,000 IP tables, and that can actually make DNS lookup become very, very costly, and that will cause latency issues. Dapr has none of that. Dapr does not use IP tables for service invocation, and like 8 of the 9 Dapr APIs do not even need service invocation. There's one API that allows you to do service and agent discovery, which does, and that does not use IP tables. Dapr actually creates Kubernetes services on your behalf. It's aware of where their services are running, and it essentially invokes the endpoints without needing to resort to the IP tables. So that's a much more lightweight way of doing that, and so you don't get this linear drop in performance with the rise of services.
Got it, and that makes a lot of sense to me. I got to ask this as a follow-up of, people naturally saw the Istio use case as solving, multi-cluster challenges, and that's kind of where my mind is right now. So with Dapr, let's say I have microservices in one cluster and another set of microservices, another cluster, maybe Redis in a third one. Does Dapr help kind of routing requests and dealing with multi-cluster architectures any easier than if you weren't using Dapr?
Yeah, for sure. It's definitely not one of the core use cases to Dapr, but specifically, I know of a lot of companies that are doing that. And there's multiple ways of doing that. So if you're watching this and you're interested in doing multi-cluster communication with Dapr, please reach out to us at Digrid. Would be happy to help. But yeah, you can definitely do that. For example, if you have two EKS clusters that are VPC peered, you can put a gateway on each one. You can actually Dapperize each one of those gateways, and then you get seamless service invocation between those two clusters, and it really works like a charm.
Got it. Yeah, and yeah, that's kind of the track that I was thinking this could be very helpful. But sorry, I think I've already taken you enough off track here, and everyone here probably just wants to see these agents battle it out or figure out how to get the ring from Mordor. So let's get
yes, the task at hand is to plan a way to Mordor. I think the final battle might be another demo. Plan how to fight Sauron, for example.
Yeah, you need a few orcs for that.
Right. Yes. Right. We can have work microservices. That's fine. We can come up with that. Actually, it's a pretty good idea for my KubeCon talk later on this year. All right. Let's continue. So we have those deployments, and what I'm going to do now is just deploy those Dapr CRDs first, so that when I deploy those agents, the Dapr containers are going to pick up on which pub sub we want to use and which state store. So I'm just going to do k apply and let's do actually k-apply. Just going to do that manually for components. And so we've created those three components. And if we go back here and we do k-get components, we should see all of those different components inside of my cluster. So this is essentially the glue between all of my Dapr-enabled applications that are running within the cluster and my AWS infrastructure. And this is really all we need. So like from a platform perspective, this is great. This can be changed in different environments, as we've talked about. Not going to be spending a lot more time on that, but this is really, really useful. Okay, and the only thing we have left to do now is deploy that code we've seen before that is running all of those agents. And I'm just going to do kubectl apply and go to manifests. So we've now deployed all of these containers, and we can go here, look at pods, and watch them. Oh, wait, redundant space. And we can see that they are running. So yeah, that was fast. Dapr is very, very lightweight, by the way. The size of Dapr container is very small. You know, I don't want to pick on technologies that were previously mentioned, but Dapr has a very low footprint. You know, that project I mentioned earlier, it's a sister CNCF project. They're great stuff. By the way, we see a lot of Dapr workloads being run with Istio. So we've got the elf, which represents Legolas. We have the hobbit, which represents Frodo. We've got the wizard, which represents Gandalf. And we've got the orchestrator. And that is like the one LLM to rule them all. Let's put it like that. One orchestrator to rule them all. And it's essentially going to get the task and then decide which of those agents should be talked to first and then second. And then those agents, we will see that they will start talking to each other directly and really reason about the plan. Okay, so what we want to do now is essentially port forward to this app and kick off a task. So this pod and Dapr workflows, Dapr agents has an API that allows you to kick off a task, and then essentially the entire agentic workflow starts. So I'm going to go ahead and do k port forward, and sorry, that's the wrong port forward. Nope, not that too. Let me find the right one. We should have it here. Yep, it's that one right from the README. Okay, so I've port forwarded into this, and I actually didn't want the dev null here because I wanted the port forward working. But now we're connected from my local machine into the service that's running the LLM orchestrator. So now for my local machine, I can just start issuing HTTP commands. So let's see how that works. We have a simple client, which I'm going to be running. And that client, and let me just find it here real quick. So this is just a script that's going to be talking to that localhost 8004 here. That is essentially going to send a request to the LLM orchestrator running on my EKS cluster. And, you know, this part isn't interesting. It's just some retry and failed exceptions around the HTTP call. But what is interesting is this. This is the task. So we're asking it, what is the best way to get to Mordor? By the way, if there's people in the chat who want to come up with a different task that our Brave Fellowship can actually take and reason about, maybe let's do that. So we're going to start off with this, and I'm just going to kick this off. And in a sec, we should see workflow started successfully. That's great. So we were able to talk to that orchestrated LLM service. And if we go back here, now we should be seeing some interesting things in the log. So let's start out with this guy right here. Let me do Kubernetes logs. And yeah, we can already see that it's starting to issue some stuff. So for example, here we can see that it's triggering an agent, and it's picking agent Gandalf for step 1. It decided to go to Gandalf first. Usually it will go to Gandalf first. Why? Because we basically tasked it with finding the best way to get Mordor, and it will look at Gandalf mostly because it is the most wise and experienced based agent that it has. And when you have like reasoning agents that can actually provide like the reasoning capabilities back to you, you can also output that and see it, and that's pretty interesting. So we have this one. And then now if we refresh the logs, we can see that we now have a second step, sub-step 1.1 for the workflow. And so here we already have a 2-step workflow where we triggered Gandalf and we triggered Legolas, and we're going to take a look at what they outputted. But this essentially is a really, really great example of how Dapper provides you with durable capabilities. Because let's say Gandalf decided to talk to Legolas and ask him for advice. And let's say that, for whatever reason, and let's admit it, there's a great many reasons why Kubernetes pods might crash or just restart. The Legolas agent service would have essentially restarted. If that were to happen, the Legolas microservice would have picked up the message, the workflow would have picked up where it left off, and it would have run to completion, instead of making the entire thing just work and fail, which is what will happen if you're going to be trying to run a lot of agentic frameworks on Kubernetes today. And you'll also discover a lot of times that if you're using their native workflow engines, you'll only be able to run a single instance of them. So let's take a look at all of our other agents. Let's take a look at Gandalf. Let's see if we can see anything interesting in terms of the output that we have. So yeah, we can see that. So we can see that, yeah, we have the user. So the LLM orchestrator, it got our task, and the task was, what is the best way to take the ring to Mordor? Then it basically created on its own this specific task for Gandalf. You must identify potential allies and enemies along the way to Mordor, using your wisdom to discern who can aid us and where threats may lurk. This sounds like a very foundational task in the taking the ring to Mordor. So we talked to Gandalf first, and then we can see Gandalf reply, potential allies, the elves of, I cannot pronounce this name in Elven, Lothlorien, I think it's pronounced in. I think I did a fairly decent job. And then there's potential enemies, of course, as Mark mentioned, the orcs of Dul Guldur and the Uruk-hai of Saruman. And there we go. So, and then, this is pretty like corny. Each ally is a beacon of hope. Great. And so we continue on now to move forward from this text into the technical parts. So Gandalf received the broadcast, and then it broadcasted again. And then the LLM orchestrator got the response from Gandalf, and it basically sent it to Legolas. So let's take a look at what Legolas had to say, if at all, because sometimes the individual agents do not pick what to say anything. So yeah, we can see that Legolas, it received the request, and then I'm not going to spend too much time on this. And he said, indeed, it is wise to explore these paths before embarking on our journey. This is what he received from Gandalf, and then he provides his own point of view, with all of the allies and threats that Legolas should know, because we instructed the agent to speak like Legolas, and then his opinion was sent back to the LLM orchestrator, and so they're continuing essentially to talk between themselves. And this is essentially how we basically run this fellowship of the ring. I'm going to move on to the land graph to not spend just too long on this, but this is essentially how we can provide various tasks to agents. And the only thing you need to do to turn this from the Fellowship of the Ring to something, for example, that runs within your own enterprise and talks to your own data stores and picks up on the challenges that you're seeing is, again, and I'm going to cover this one last time before we move on. All you need to do is really take each one of those and just give them, a different name, a different role, different goal, and different instructions. And Dapper agents, this would be the good time to mention this, also supports MCP. So Dapper can, with 2 lines of code, connect your MCP server, and you can provide a bunch of tools. So for example, if you want to create an agent that talks to your, AWS Salesforce CRM integration, and just work off of that, you can easily do that with very few lines of code.
Yeah, so if I wanted to ground this in reality, as much as I love this analogy and watching them solve this this very challenging problem, let's imagine that instead of getting the ring to Mordor, the problem is, help me find out why I've had this particular Kubernetes incident or security issue or whatever it might be. And these various agents, one of them could be to pull data from my CloudWatch servers. Another might have integration into my engineer Slack channel, so it can pull data about them discussing what the problem is and use that tribal knowledge to maybe solve the problem. And each of these agents could be another potential tool. One of them obviously is probably a Kubernetes MCP server that can talk directly to your Kubernetes cluster. So I'm the wheels are turning in my head here, and I can really see the power of just by being able to abstract away these individual agents, you really can solve really challenging problems. And again, coming back to that platform engineering perspective of, the teams that are trying to solve these really typical but challenging problems don't need to be the ones that are programming the Legolas agent, the Hobbit agent. That can be handled by a central team. So honestly, really, really powerful stuff. One last thing I'll mention is that pub sub workflow approach is actually really nice for agents, especially because LLMs being non-deterministic, you don't know when they're going to come back. You don't know how they're going to come back. It might have solved the problem. So being able to subscribe to the events that are being fired, I mean, that seems like a good way to take one LLM invocation and almost simultaneously leverage all of these different tools to solve that original problem. That's really cool to me. Honestly, that's my big takeaway of this is of how well this framework caters itself to the agent use case, and our audience loves it too. By the way, they're loving all the Lord of the Rings talk here.
I mean, we can work with a very practical example here. We've been working with a logistics company there, and the logistics company has kind of pretty strict criteria each day about getting particular things shipped from their warehouse. Well, as you can imagine, it's a very dynamic environment. Orders change, different shipment cycles happen, emails are coming in. And so we've worked with one company where they built an agent that dynamically looks at emails that are coming in, looking at the requests that are going out, so it's looking at their database store, it's looking at emails, and the agent's basically working on behalf of the warehouse manager, looking across the logistics, and basically kind of being side by side, making sure that, have you got this checked today, have you got that, basically doing queries on agents across his data and informing him about what he should be doing, and kind of augments the job in his role. And it's proved highly effective in improving the productivity of that warehouse logistics manager in terms of.
Yeah, and in this case, by the way, you mentioned earlier, just having a different type of agent that connects to your database. This is what we have here. So this is essentially all you need to do. You just take an MCP client, connects to an MCP server. This can be whatever you want. This can be like an AWS data lake. And then you can essentially just then fire off queries like, show me all of the latest churning users for the past month, just by the virtue of doing these 6 lines of code, right? And so this agent will, and we have this in our examples, in this case, it'll connect in our example to a Postgres database, which can be an RDS, and it'll scan all of your schemas, and based on the questions you ask it, it'll actually pick the right schema to formulate the query. It'll actually construct the query and then answer all of your questions. So it's essentially like talking to your database via natural language. And by the virtue of Dapper, with this single YAML file, you can connect your environment to it. So similarly, if Kubernetes has an MCP server, this is literally all you need to do. You basically change this to like Kubernetes, and you don't even have to change names just for fun, and just call it like Kubernetes DevOps, And then this is really all you need to do. You just need to run a Kubernetes MCP server. You'll issue a query like, get me all of the pods that have restarted over the last month. It should be able to do that really, really easily.
Yeah, this is really cool. And Yaron, I think while the AI agents piece is a really interesting and cool use case of this, I don't know. And this is a question to either of you. This is just one application of this of Dapper, right? And I think that's kind of what's really interesting to me is that Dapper has been around for a while. Customers are using it to build all sorts of different workflows and applications. And it seems like without much change, you were able to apply this to agents as a use case. So I'm curious to hear a bit more about that. Of what are some other really popular use cases that you're seeing customers leverage Dapper for today?
So workflows is definitely something really exciting because although Dapper Agents has workflows built in, in many cases, you just want to build a workflow yourself. You want to orchestrate a bunch of processes. Imagine you have 10 different applications running on EKS or, even on ECS. And you basically want to make sure that they all coordinate their state and, that you can essentially coordinate the calling between one service and the other and make sure that if one goes down, then the workflow picks up. Dapper has a very general purpose programming model to do that called Dapper Workflows. And then we've kind of touched on that before. If you want to create pub/sub applications in AWS, you don't have to code against the AWS services. You essentially only code through the Dapper client, and you can do that easily, and then just connect it to your pub/subs of choice, which can be SQS in this case. So making event-driven applications, doing things like using the Dapper APIs for cryptography to encrypt state, doing leader election with Dapper is very, very easy. I mean, think about it. It's a very hard distributed systems challenge to make sure that if you have 3 active replicas of your application, that only one is active, because you need to do like locking on separate databases, and it's very gnarly to do. But with Dapper, you get an API and an SDK to do that, and it literally becomes 5 lines of code. So we have a whole bunch of these, and I really encourage users to go into the Dapper references, which we'll share at the end, and see all of the Dapper use cases that this project allows you to do.
Yeah, and
awesome.
That includes secrets APIs as well for managing secrets, which is a very common thing. Pull secrets down, and state management, storing state for like the state of a shopping cart and key value store and data and pulling that out. So yeah,
got it. And folks, so sorry, really quickly. So we're kind of coming up on the end of our time here, and just as a quick recap for folks that may have tuned in halfway through, Dapper is an open source CNCF graduated open source tool. Essentially Dapper coming from distributed application runtime. And today we saw one example of how we can apply that approach, that framework, to AI agents. But of course, a lot of other use cases here. Yaron, Mark, I want to give you two a chance to quickly talk about the company behind this Diagrid. Dapper being an open source capability. Why should customers think about leveraging Diagrid, some of the managed capabilities that you have?
Yeah. So I mean, Diagrid, we're the primary maintainers of the Dapper project. Both and I, with Yaron, we're the co-founders of the project. We're also maintainers of the project. So we have a huge engineering team that effectively contributes into the project and that kind of helps maintain that. And so our role is to make sure that we grow the Dapper ecosystem, grow its adoption. There are over 40,000 companies using Dapper today. The ecosystem is larger and larger each year. And so at Diagrid, we provide a couple of services there. One is that you can come to us in order to help with support in terms of getting support for the open source project. We have some amazing tools as well for managing Dapper on top of Kubernetes, doing debugging and doing effectively helping you to resolve incidents inside of that. So we provide that as Diagrid Enterprise. And then we actually provide a platform play as well. That platform effectively allows you to deploy effectively. Think of it as a server-like experience. We call it Diagrid Catalyst, and you can deploy that into your environment and effectively be able to deploy your applications beyond just Kubernetes. And I think that's the key. If you want to deploy, for example, an application onto a VM or onto, if you want to use Lambda functions instead, and you want to build applications that run elsewhere, but utilize all those great Dapper APIs, Catalyst, our platform we do at Diagrid, allows you to effectively build those distributed applications and yet take advantage of all of the great capabilities, particularly workflow around that. So
Yeah, it also provides visualizations on top of workflows. So with that platform, you can visualize your agents, you can visualize workflows. You get really for platform teams, you have the ability to onboard teams and create environments for them and projects and assign developers to specific infrastructure. So there's a lot of centralized governance and the ability to just consume Dapper centrally from within the organizations and save a lot on just resources and costs.
Excellent. And folks, I have to tell you, I was excited to get you on today because I've spoken with multiple customers leveraging Dapper for various use cases running on Amazon EKS. Of course, from the AWS side, with EKS and specifically with EKS Auto Mode, we're starting to help customers manage more of their data plane, right? Their worker nodes, making it easier to run workloads. And that combined coming from the other end of these developer-focused application runtimes really means it's easier than ever to build highly available, scaled, resilient workloads on Kubernetes. And I think together we're seeing that these two tools really do work for a number of different use cases. Today, of course, we saw AI agents being a very fun one that we were able to kind of show in such a short amount of time. So, Yaron, I want to thank you for that demo. Okay, in our last few minutes here, how can folks get started? How can they get involved? Is there any good way to get your feet wet in the Dapper ecosystem?
Yeah, by far the best way is dive in. There's a site, dapr.io, where you can go and see that, but it really takes you quickly down to the getting started guide. It's super easy to install Dapper. You just download a CLI, you run a Dapper init command, it sets up a local development environment for you. There's a set of quick starts that walk you through each one of the APIs, try out each one of those quick starts, whether it's workflow or pub sub, and how you're thinking about those. And then from there, actually, you can then go off and join our Discord channel. It's a big, vibrant community there. There's plenty of channels you can ask questions on. We love the Discord community. That's where a chance to kind of engage, whether you're working with a particular language, like Spring Boot integration with Java, there's that community inside there. Or if you're using Dapper, just a particular API, come to the Discord community and have a chance there to kind of engage with us. And come and contribute. I mean, more than anything, we want people to contribute to Dapper, the open source project, become part of the ecosystem. You can contribute everything from introducing a new component, to some favorite infrastructure you have, to even helping out with some of the samples and documentation. There's plenty to do inside all this. So that's something that we love and we live for, particularly growing the community and making the project thrive all around.
Awesome. Yaron, any closing remarks, anything you want to share with our audience here?
Yeah, just something I didn't get to show was how Dapper can really be useful with existing agentic frameworks. So, we talked about Dapper agents, which is its own framework, which is great. We are going to have samples showing up how to use Dapper, in like AWS strands and making that durable and stateful and also other agentic frameworks. So be on the lookout for that within the Dapper Python SDK and within the Dapper Agents SDK.
Yeah, we're really excited about Agent Core and Strands and the approach that we take with building AI agents. And the whole time I was thinking, Dapper can likely link with these tools to make them even more durable and make them easier to develop. And of course, with agents, there's a whole different set of challenges to solve, and being non-deterministic, trying to reduce how long it takes to get your first token out. These are all challenges that developers are dealing with. So, Yaron, I'm going to hold you to that. I'm expecting to see a sample around this soon, and maybe we'll get a blog written around this as well. I'd love to see something showing how these two capabilities can work together. All right, and with that, folks, thank you so much for tuning in today. Yaron, Mark, thank you for joining us, talking through the solution. We appreciate the time that you provided us today. And for our folks watching, subscribe to the channel if you want to see more episodes like this. And you can see their tags there for Mark and Yaron. Feel free to add them and bug them directly. Thank you, folks. And thank you, Mark and Yaron.
Bye-bye.
Thank you.